Using a calculator, we're going to fill in the value of the trig ratios for the given angles. So in my calculator, I'm going to hit sine of 30 degrees and I get 0.5. I'm going to hit sine of 60 degrees and I get 0.866. And there's more decimal places, but I'm just going to write down the first three. I'm going to type in cosine of 30 degrees and I get 0.866. I'm going to type in, and there's more decimal places after, cosine of 60 degrees, and I get 0.5. Please pause the video. I'm going to pause the video as well and fill in the rest of the chart using your calculator. So I filled in my chart except for cotangent. Remember that cotangent is the reciprocal of tangent. So I can type that into my calculator as 1 divided by tangent to get cotangent. So if I want cotangent of 30 degrees, in my calculator, I'm going to type in 1 divided by tangent of 30 degrees. And I'm going to hit enter, and I get 1.732 and then some more decimal places. And if I type in 1 divided by tangent of 60 degrees, I get 0.577 and continued. Please find the cotangent values for the 50-degree angle, the 40-degree angle, the 47-degree angle, and the 43-degree angle by typing in 1 divided by tangent of 50 degrees, 1 divided by tangent of 40 degrees, 1 divided by tangent of 47 degrees, and 1 divided by tangent of 43 degrees. So now that our chart is completely filled in, let's answer the questions that are at the bottom. It says, what is the sum of the angles in each table? Take a look. What are the sum of 30 and 60, 50 and 40, 47 and 43? They all add to 90 degrees. In each table, what functions are equal? So in table 1, that's the 30 and the 60-degree angles. I notice that sine of 30 degrees and cosine of 60 degrees are equal. Also, sine of 60 degrees and cosine of 60 degrees are equal. And over here, tangent of 30 degrees and tangent of 60 degrees are equal. And tangent of 60 degrees and cotangent of 30 degrees are equal. And if you take a look at table 2, I notice the same pattern. Sine and cosine are equal. So are they here as well. Tangent and cotangent are equal. And if you take a look at table 3, for this angle measurement, sine is 0.731. And for this one, cosine is as well. Sine and cosine here are also equal. Tangent and cotangent in this table are equal. And over here, tangent and cotangent are equal as well for the 43-degree angle and the 47-degree angle. Let's try to come up with a rule for what we noticed. Well, I noticed that for the angles that add up to 90 degrees, sine and cosine are equal. And that's because sine and cosine and tangent and cotangent are cofunctions. So here is a rule that defines what is happening in the table. So sine and cosine are equal to each other when their angles add up to 90 degrees. That's what we mean by cofunctions. Tangent and cotangent are also cofunctions. So they're equal when their angles add up to 90 degrees. And they don't come up too often, but secant and cosecant are also cofunctions. So secant and cosecant are also equal when their angles add to 90 degrees. And we can see that in the table over here. Sine of 30 degrees and cosine of 60 degrees were equal. Their angles added to 90 degrees. Tangent of 50 degrees and cotangent of 40 degrees were equal. Their angles added to 90 degrees. Sine of 47 degrees and cosine of 43 degrees were equal when their angles added up to 90 degrees. So I'm going to write that over here. Sine and cosine and tangent and cotangent are equal when their angles add to 90 degrees. And that means that they are cofunctions. So let's do an example using this fact that sine and cosine are cofunctions. So if x and x plus 20 are measures of two acute angles, and sine of x equals cosine of x plus 20, find x. So since sine and cosine are cofunctions, we know that they're equal when their angles add to 90 degrees. Here is the sine angle, and here is the cosine angle. So I want to make an equation that says when the angles add up to 90 degrees, that will give me the x value where sine and cosine will equal each other. Since sine and cosine are equal when their angles add to 90 degrees. They're cofunctions, meaning they're equal when their angles are complementary. That's where the co comes from, because they're equal when the angles are complementary. So that's 2x plus 20 is equal to 90. So we have 2x is equal to 70. So I have x is equal to 35. For each of the following, write the expression as a cofunction. So sine of 80 degrees would be equal to cosine of what makes 90 with 80? 10 degrees. Cosine of 67 degrees would be equal to sine of what makes 90 degrees with 67? 23 degrees. And tangent of 72 degrees would be equal to cotangent of what makes 90 degrees with 72 degrees? 18 degrees. Let's check out this next example. If cosine of theta is equal to sine of 60, find cosine of theta. So I know that cosine and sine are cofunctions, so they're equal when their angles add up to 90 degrees. So my equation should say when the angles add to 90 degrees, that's the value of theta that will make cosine and sine equal. So if I subtract 60 degrees from both sides, that would be a 30-degree angle. And it asks for what cosine actually is. So cosine of the 30-degree angle would be, if I type it into my calculator, I get a really long decimal, 0.86666. But luckily, I know a right triangle that has a 30-degree angle. And that's our special right triangle, the 30, 60, 90 triangle. And remember that 30, 60, 90 triangles have sides that are in the ratio 1 to radical 3 to 2. So focusing on my 30-degree angle, cosine would be adjacent, which is radical 3, over hypotenuse, which is 2. And that would be my exact value of cosine of 30 degrees, rather than getting that really long decimal that goes on forever that I have to round, which wouldn't be an exact value. For the next one, tangent and cotangent are cofunctions. So they are equal when their angles add to 90 degrees. It's just asking me to find x. So I have x is equal to 20. Okay, I'm going to skip over to here. When instructed to find the length of HJ in right triangle HJG, Alex wrote the equation sine of 28 degrees equals to hj over 20, while Marlene wrote cosine of 62 degrees is equal to hj over 20. Are both students' equations correct? Explain why. Take a minute, pause the video, and think about this question. Feel free to draw the diagram on your paper and mark it. The answer is yes. Both students' equations are correct. And the reason for that is sine and cosine are cofunctions, so they are equal to each other when their angles add up to 90 degrees. And here, their angles, 62 and 28, do add up to 90 degrees. So that tells me that sine and cosine will be equal. They will have the same value because their angles add to 90 degrees and they're cofunctions. And if we check it out here in the diagram, here's the 28-degree angle. So sine would be opposite, which is hj, over hypotenuse, which is 20. And if we instead focus on the 62-degree angle for cosine, which would be the angle right over here, because 28 plus 90, subtract from 180, gives you 60 left over. Cosine of the 62-degree angle would be adjacent, which is hj, over hypotenuse, which is 20. So we can see also from our trig ratios that these are the same. I'm going to type my explanation over here. Yes, both are correct because sine and cosine are cofunctions. So they are equal when their angles add to 90 degrees, and 28 plus 62 does equal 90 degrees. Your explanation could also mention how both of the trig ratios are correctly set up. This would be from the 28-degree angle opposite over hypotenuse, and from the 62-degree angle, this would be adjacent over hypotenuse. But I think it's easier and goes along with the topic of this video to use the cofunction explanation.